You know that chart you see in pretty much every science classroom, the periodic table? It looks like the absolute definition of order and logic, right? Well, it was actually born from a century of total and utter chaos. So today, we're going to dive into the incredible story of how humanity's greatest scientific cheat sheet was created.
Okay, so picture this. It's the middle of the 1800s. Chemists have discovered more than 60 different elements, the basic ingredients of our entire universe. But they were basically just sitting on a pile of puzzle pieces with no picture on the box to guide them. Every element was just its own little island of information with no clear connection to any other. And the confusion was, it was rampant. It got so bad that chemists couldn't even agree on the most basic things, like how much a single atom actually weighed. You'd have a lab in France getting one number and a lab in Germany getting a totally different one. This wasn't just messy, it made it almost impossible for science to move forward. Chemistry was pretty much stuck.
So, that's our starting point, a world of pure chemical chaos. Scientists had this growing list of amazing discoveries, but absolutely no system to make sense of any of it. So how on earth did they find a way forward?
Well, the turning point came in 1860. The world's top chemists got together for their first ever international congress, basically to try and sort this whole mess out. And there, an Italian chemist named Stanislao Cannizzaro presented a totally game-changing method for reliably measuring atomic masses. And just like that, for the first time, everyone was speaking the same language. With this new, standardized data, the race was officially on to find the hidden pattern connecting all the elements.
And this is where our main character enters the story, a brilliant Russian chemist named Dmitry Mendeleev, who saw all this new, reliable data as a huge opportunity. He decided he was going to be the one to take on the grand challenge, organizing the very building blocks of the universe.
Mendeleev's method was so simple it was genius. He just made a card for each of the 63 known elements, jotting down its name, its atomic mass, and its unique properties. Then, he started playing a kind of chemical solitaire, shuffling, arranging, and rearranging the cards over and over, just looking for some kind of pattern. And then, he saw it. When he lined the elements up by their increasing atomic mass, their properties started to repeat in this predictable, almost rhythmic way.
And that repeating pattern, that's what we call periodic. It's like the second hand on a clock. It hits the 12 every 60 seconds at a regular interval. Or think about the phases of the moon. Mendeleev discovered that the properties of the elements had their own natural rhythm too.
A great way to visualize it is like ripples spreading out from a single drop of water in a pond. They always follow the same pattern. The elements did the same thing. You'd get a super reactive metal, then a few less reactive ones, then maybe a gas, and then boom, the pattern would just reset and start all over again with another highly reactive metal.
Now, this groundbreaking insight into these repeating patterns wasn't just some neat trick. No, it was the key to creating a whole new map for science, the very first periodic table.
And this is it, his actual first published table from 1869. By grouping the elements that had similar properties into columns, he created the first real map of the elements. All of a sudden, you could see this clear family resemblance between elements like lithium, sodium, and potassium. It was a totally revolutionary way of looking at the building blocks of matter.
But this is what separates a good scientist from a true genius. See, Mendeleev didn't just organize what was already known, he had the audacity to challenge it. First, he left deliberate empty spaces in his table, basically saying, hey, there are elements that go here, we just haven't found them yet. And second, he even broke his own rule, swapping two elements because their properties told him the pattern was more important than their measured mass. He trusted his system more than the accepted data. Incredible.
Can you imagine leaving empty spaces on a brand new scientific chart was an incredibly daring move. It totally opened him up to ridicule. Was he just guessing? Or did his tables somehow reveal something much, much deeper about how the universe works?
And this is the moment that just cemented his legacy. He didn't just leave gaps, he made predictions that could be tested. Get this, he described an undiscovered element he called ecosilicon, predicting its atomic mass, its density, even what color it would be. And then, 15 years later, a German chemist discovered a new element, germanium. And its properties? An almost perfect match to Mendeleev's predictions. The man hadn't just organized the present, he had predicted the future.
Mendeleev's table was an absolute masterpiece, but the story isn't quite over. Science is always refining and improving, and his amazing work needed one final, modern update to solve the last few puzzles and become the chart that we all know today.
So, decades later, a physicist named Henry Moseley found that final key. He discovered that the truly fundamental property of an element isn't its mass, how heavy it is, but its atomic number. That's its core identity, based on the number of protons in its nucleus. And when you reorder the table by that number, all those little exceptions Mendeleev had to fix by hand, they suddenly just snap perfectly into place.
And that final tweak brings us to the modern table, a complete and incredibly powerful tool for decoding the rules of chemistry. So let's do a real quick breakdown of how to read it.
When you look at the table today, just remember these two things. The vertical columns are called groups, and all the elements in a single group behave in really similar ways. They're like chemical families. And the horizontal rows are called periods. As you move across a period from left to right, the properties change in that predictable, repeating way we talked about. It's the periodic law made visual. But this all raises one final, much deeper question. Why does this elegant pattern even exist in nature in the first place? Well, the answer isn't found in a chemistry lab here on Earth, but way out in the cosmos. This image here shows a nebula, which is the beautiful aftermath of an exploding star. This stellar forge is where the elements are actually born. So here it is, the most incredible takeaway of all. The perfect, elegant order we see in the periodic table is a direct reflection of the violent, chaotic death of stars. That chart hanging in every classroom isn't just a list of chemicals, it's a map of the universe, forged in cosmic fire. It's an amazing reminder that hidden deep within the chaos, there's always a pattern just waiting to be found.